1, go.
Hey guys, my name is Daniel. I'm once more part of the education staff here at the Challenger Learning Center. Today, I'm coming to you again, but this time we're going to be looking at a density tower or a density column using 9 different liquids right here. We're going to build a tower out of these 9 liquids. Let's come on in a little closer. We can look at all these. The leftmost one is honey. The second one is corn syrup. Third one is maple syrup or some sort of pancake syrup. The fourth one is milk. Any type of milk is fine. Fifth one is dish soap. The sixth one is actually water. It's just dyed blue. And the seventh one is vegetable oil. The eighth one is rubbing alcohol. We have that dyed red. And then finally we have lamp oil on the end as number 9. So let's talk about what density is before we jump into the actual experiment. Density, if you don't already know, is how much stuff, whatever takes up a particular volume. So it's a mass per volume. Don't worry too much about any particular units. Typical ones it's about like grams per centimeter cubed or grams per milliliter. I'm sure you'll learn more about that as you go further in school. But don't worry about what the units are, but it's just how much mass fills a particular volume. Just know that, okay? I will give you a value. Water right here, just for reference, the density of water is 1.0, meaning that in general, a mass of, say, 1 gram fills 1 milliliter of volume. So it's just a basic starting point for a density value, and then we're going to see how these densities change, or not change, but how they are with relation to what the water is at 1.0. And I'll actually tell you what these values are at the very end. Okay, so hang tight for that. So let's go ahead and get started. We're going to go ahead and carefully pour these in this order into our graduated cylinder. You don't have to have this particular one. This is just the one that we had at the Challenger Learning Center, and I brought it home with me to do this for you guys. Just have like a tall kind of container. If it can be glass or something that's clear, that's best, so you can see in it. And again, you do not have to have these 9 liquids. It's just whatever you have at home. Okay, whatever you can pull out of the pantry, whatever you guys have at home, and it doesn't have to be 9. It can be less than 9, it can be more than 9. So have fun with this. It's really up to you and what you guys have at home. So here we go. You guys ready? Here we go. Number 1, we have our honey. The trick is, for the honey and the stickier items, you want to not touch the edges of the cylinder as best that you can. Just going to take a little bit of patience. Yeah, you can kind of come on in just a little bit and try to get this in. One note I did forget to mention while I get all that honey in. If you notice that the liquids were the same amounts in every cup, make sure that every liquid is the same amount. That way every layer is pretty close to as equal as you can get it, okay? That way you don't have something that's more than the next in terms of the depth of your layer. I'm going to try to get a little bit more of this honey out. And then we'll move on to the corn syrup in just a minute. Just give me a second. I think that's about good here. I guess I could grab a spoon. Just bear with me. Let me grab a spoon and try to get this out of here. Just want to make sure that we have the entire amount here. And in each cup I also have about a half a cup of each liquid. You can do quarter cup, third cup, whatever you want. Just like I said, make sure that it's the same amount of every liquid. Okay, there's our honey. Layer number 2. Got our corn syrup right here. Again, you do not want to touch the edges, just carefully. You want to go and come on in a little closer. Look at how they are interacting. They should not mix because the densities are different. So what do you guys see that's happening there? You guys see that the corn syrup is on top of the honey? Can you see that? That means that the density of the corn syrup is less than the honey, and therefore it's on top of the honey. Yeah, there you go. And it's okay that they're mixing a little bit. The longer that it sits, the more that they will begin to separate into their individual layers, and that's what we want at the end. So we'll carefully continue. Just be very cautious that you pour them in very slowly. This is our maple syrup, or our pancake syrup. Let's see what we have going on here. Carefully pouring this in. Let's see, let me use my spoon again. Get all the goodness out of here. Okay. So what do you guys see there? The maple syrup is definitely on top of both the corn syrup and the honey. Therefore, the density of the maple syrup is less than the density of the corn syrup, which is less than the density of the honey. Okay, that's our first three. Now, the milk is going to get a little trickier. The instructions that I found was to use a pipette. You can always use a turkey baster or some kind of baster that you have in the house if you have one. We want to carefully and slowly dribble the milk on top of the maple syrup. Don't want it to go too fast. You don't want to just pour it in. So we're going to go nice and slow as we get this in there. Just kind of bear with me. It's going to take a little bit of patience, but just better to be safe than sorry in here, because you don't want these to start to mix, which they won't mix if the densities are different. So we'll see how they vary here. And you don't want this to touch the sides either, so keep that in mind. So just pour it, or not pour it, but use the baster or your pipette to put it right in the middle of the container or the cylinder or whatever you have available at your house. So you can see that the milk definitely has, let's see, yeah, it's clearly on top of the maple syrup. So therefore the milk density is less than the maple syrup. You guys can see that, which again is less than the corn syrup, which is also less than the honey. I might try to pour this in just a minute, just nice and slowly. But the big thing is you do not want this to touch the sides. Now, we will get to the water and the alcohol, or the rubbing alcohol. Those can touch the sides because they're more of a liquid form. This, as far as I understand, if it, like this in the dish soap in particular, if it touches the sides, it can kind of coat the sides, and that might mess up the individual layers that we would have. I'm tempted to pour this in, but I don't want the layers to get messed up. I think since we have a foundation layer, it should be pretty good. I just don't want to go too fast with it. But yeah, I don't want to be here for, half hour. Keep the suspense waiting. I might go ahead and just see if I can pour a little bit in, just nice and slow, nice and slowly. You can see it's mixing. It mixes a little bit, but then it comes right back up. You guys see that? Go and come on in just a little bit. Look at the layer that's dividing the milk with the maple syrup. You can see it's kind of bouncing in there into the maple syrup layer, and then it comes right back up. That's pretty cool. What do you guys think? Yeah? That's nifty. Okay, so we got 4 layers done. 5 to go. So we got our dish soap next. Of course, this can vary in looks just based on, brand or whatever you guys have them. I've seen like green and orange, and this one's is a light blue. Let's see if I can get this into the pipette. This calls for the pipette again, because if you don't want to touch the sides. Once I get this in here, Let's see if I can get this. This is really not sucking it up as good as the milk. I actually might pour this in. Okay, let's see. Fingers crossed that this works. But the thing is, you want to go nice and slow. And again, you do not want to touch the sides, so keep that in mind. Take a close look at the kind of boundary between the milk and the soap. It kind of goes in and then it comes right back up. So the densities of the milk and soap are definitely different, with the soap being clearly less than the milk. Bear with me, let me grab another spoon really quickly. I don't want to use the same spoon that I used for the honey and everything. Ideally, you would want to use a pipette or some sort of baster for this, but it really wasn't working in terms of getting the soap up. And I know I did hit the edge, but that should be fine. So you can see it kind of mixed a little bit with the dish soap and the milk, but in general, the dish soap did remain above the milk, and therefore, we can see that the density of the dish soap is less than the milk, as previously discussed. I'm going to set these aside out of my way. Then we'll move on to the last 4 liquids that we got here. Okay, so we got water next. Remember, this is a density of 1.0, just for reference. I'm going to use a pipette. This one, we can touch the sides because it doesn't really coat anything. You just want to go nice and slow to try to get that going in there nice and slowly and not mixing with the dish soap or milk or anything below there. You want distinct layers as you can get. And like I said before, the more you let this sit, the more the layers will separate. But for now, it might take some time, especially like with the honey and the corn syrup, and the milk with the dish soap is a little tricky. Those are the tricky layers. Okay, I'm gonna see if I can pour this in carefully. I think I'm gonna tip it just a little bit to try to get, let me see, maybe not. I'm gonna try to, this is worrying me a little bit. Trying to get it in there. Okay, come on in, look at the boundary between the dish soap and the water. I think I see some of the water kind of going under the boundary, but then it comes right back up. So therefore, the boundary between, or the density between the water and the dish soap is definitely different. Look at that. So there's your water in dark blue. The dish soap is in the light blue, and then your milk is, of course, the white. So the density of the water is definitely less than the density of the dish soap, which is less than the milk, and less than the remaining layers down here. Okay, so what do we have? 1, 2, 3, 4, 5, 6, done. 3 more. Okay, vegetable oil is up next. I'm going to just pour it in nice and slowly. Ideally, you would want to use a baster if you had a lot of extra time. But I think pouring it in slowly should still work. Granted, the dish soap is soapy, and that's getting over everything. But we can look closely at it. Okay, look at that. Okay, I think we're seeing a clear difference between the water and the vegetable oil. You guys want to come on in just a little bit? You can see that, oh, it's going to separate. Look at this. Look at this at that dark blue line. That should get bigger as the oil, we all know that oil should float on water, and here we're definitely proving that. Oil will float on water, so this layer, this dark blue layer, should get bigger as we let it sit. As we go on to the other layers, we'll see how that is. But we can see that the oil definitely floats on top of the water, therefore the oil is less dense than the water, which is less dense than the other remaining layers beneath it. Okay. Rubbing alcohol, we have 2 layers left. Okay, here we go. Just gonna slowly pour this in, and hopefully we can see distinct layers here. Ooh, the alcohol is popping the soap bubbles. That's good for us to see it better on top. Look at this, guys. What do you guys think? You can see clearly that the alcohol is less dense than the oil, which is less dense than the water, and so forth. Okay, we're seeing, look at this dark blue boundary. It's getting bigger. See that? That's interesting. So we have our water right here and our rubbing alcohol here. The soap bubbles here should go away after a while, but the oil, or the oil is definitely between the density of the oil is definitely between the alcohol and the water. Last but not least, we got lamp oil. If you don't have lamp oil at home, it's not a big deal, but we're gonna see what this does. I'm gonna pour this in nice and slowly without splashing this out. Okay. Look at that, guys. Okay, so we are definitely seeing the lamp oil on top of the alcohol, which is on top of the oil, which is on top of the water, which is on top of the dish soap, on top of the milk, on top of the maple syrup, on top of the corn syrup, which is on top of the honey. That is your 9-layer density tower. And like I said, over time, the longer you let it sit, the more these layers will become more defined. But in the meantime, since we are more, short on time, I think we're good to go with testing out some different items. Okay, we have a bolt. We got some washers here. We got a ping pong ball. Yeah, you can come on in and take a look at this. We got a dice that you would use in a game. We got a cherry tomato. We got some marbles, some beads, a soda cap or a water bottle cap, and this is a popcorn kernel. We are going to see how or where these land in our density column to try to decide some basic density values or ranges for these items. Keep in mind that this, like we said, water was 1.0 for the density value. Again, you don't really need to worry about what the units are at the moment. I just want to give you numbers for now, just as a reference. You'll learn more of the units as you go on in school, but for now I just want to focus on the values, on the numbers themselves. So let's go ahead and start with the bolt. Okay, we have, when we drop this in, whoa, look at that, guys. Where'd it go? It went into the honey because it is the most dense item that I believe we have here, and therefore its density is pretty high compared to water and even the dish soap and stuff. We have some marbles here. Let's see where these go. I have a bigger marble here. Where's the marble go? Okay, it's about the same as the honey. Now I have a smaller marble. Just drop this in. Interesting. So they're about the same. So they're down with the honey. Here's some bolts. Just want to see where this. Okay, that goes to. No, it goes to the honey. Okay. Ooh, dear. Okay, so they all go to the honey. All the bolts do. Let's go ahead and try a dice here. See what we can do here. See where the dice is. It's somewhere. Oh, it's right here with the maple syrup. Look at that. Look at that. So the density of the dice should be about the same as the density of the maple syrup. Let's try the cherry tomato. I know that seems like a random item, but hey, you can use whatever items that you have. This is not a set in stone item. Look at this. It's a little bit more than water. It's kind of between the water and the dish soap. Very interesting. So it's about 1, maybe a little bit more than 1. Here's a soda bottle cap. Let's see where that goes. So that goes about the lamp oil area. Lamp oil to, I don't know, rubbing alcohol in general. We got some beads here. See where those go. Got about 4. One went into the soda cap bottle. Okay, they're going. Okay, they're going to the dish soap here. So they're about the same as the cherry tomato, maybe a little bit denser. They're about in the soap area. Here's your popcorn kernel. See where that goes. Okay, it's about the lamp oil. You can see it right in there. Here's your lamp oil in there. It's about the density of the popcorn kernel. And last but not least, our ping pong ball is actually the least dense item that we have here. So it floats right on top of the lamp oil. The lamp oil is the least dense liquid that we have, but the ping pong ball is the least dense object that we have here. So you can use whatever items that you have to, see the density of different items here that we have around the house. Not only liquids, but also items too. Okay, so I just wanted to close by just explaining once more this whole density column that we have. 9 different layers. Again, you can use whatever items that you have around the house, nine different liquids, or fewer than that if you need to. You can put in any items that you want, and you can make it your own, which is pretty cool. I did want to run through some density values that I have here. Like I said, water is 1.0. Vegetable oil, of course, is less than water. It's actually 0.92. Milk is a little bit more than the water. It's down here, 1.03. Dish soap is 1.06 or so. So it's pretty close to the milk. Corn syrup, 1.33. And maple syrup is 1.37, or pancake syrup was about 1.37. So they're about close. This particular kind that we had, the pancake syrup or the maple syrup, was a little less dense than the corn syrup. Again, like the dish soap and the milk could vary based on the type of milk that you have. I'm sure whole milk would be fattier, and that might play a role in the density value. And then honey, of course, is the most dense that we have here at 1.42. Okay, so that's your density column there. I hope you guys learned a lot. Again, make sure that you use whatever you have in the house, and also work with your parents on this. It's very important that you work with them so you know how to handle these particular items that you have in the house, as well as being able to dispose of them safely. Okay, very, very important that you do. Thanks for joining me. I hope you guys learned a lot. Have fun making your own density columns. I'll see you guys later. Hey guys, bonus footage here. We have this sitting after about an hour, so come on a little closer. I want you guys to really get a good view of the separation of our 9 layers. One tidbit I forgot to mention to you is that if you do not have the correct layer of most dense to least dense from bottom to top, that's okay. Like I referenced during the main video, make sure that you add each liquid very, very slowly. Even if you have a more dense item that you put on top of a lesser dense one that you have, it should, if you add it slowly, it should go through the less dense item or liquid in this case, and it should go through and settle to whatever layer order it is based on the density. So I wanted you to take a look at this. Again, let it sit for some time. Use what you have at your house and have a great time with it. Catch you guys later.